point right here. And this is the unit circle. I know it's not a perfect circle, but like, yeah. So this order pair would be like the cosine of theta and the sine of theta. So that would mean that this length here is the cosine of theta, and then this length here would be the sine of theta. So like this is your y value and your x value. Okay, so just kind of like, does y'all understand that before we proceed? Okay, so we're gonna do some examples of these because that's the best way to like practice and implement those hints we just used. So, yeah. Okay.
Might want to put that arm down.
Okay, so with these problems, the directions of this would be probably like to prove this equals this. So when you look at that, you probably don't see right offhand that they equal each other. So the first, what we're going to start with is those hints that we just wrote down. And so the first hint, if you look on your note card, it says start with the more complicated side. So when you approach this problem, which one of these sides is the more complicated side? Right, the left side. Tangent x times cosine of x is a lot more complicated than just sine x. So we know that we're going to start working on this side. So okay, we like have like one place to start, and we wrote down that you're only going to work with one side. So we're not going to like start doing things over here and then do things on this side. No, you're going to like work on one side. So I guess you just little arrow. And we're going to start on that side, and then you're like. The next place to go to is to think about changing all the terms to sine and cosine. So if we're just working with this side, this is already cosine. So what can we change tangent to get it in all sines and cosines? Like what's one of the identities you just wrote down?
Look at your note cards.
Right, so tangent x is equal to the sine of x over the cosine of x. Everybody see where that came from? Yeah? Okay. So that's tangent x, and so then you still bring down your cosine x, and it still times cosine of x, and it equals, this is what I just brought down, the sine of x. Okay, so what can you see that you can do on this side? Right? So cosine x and cosine x cancel out, so you're left with just sine x equals sine x. So that's verified, right? Check. Got it? That makes sense?
So it's like a yes or no thing?
Yeah, well, I mean,
You're proving that it's equal to that.
yeah, like
Yeah.
this side is going to be equal to this side, but you just have to show that. So it's like proofs. Okay?
But not geometric proofs.
What'd you say this time?
Or you
Not
make things so much more
geometric
complicated.
proofs.
Oh, you're talking about.
I make things more complicated?
Geometric proofs always.
So what kind of proofs are these?
These are trig proofs.
Okay. So another example. So if we look back to our note cards, we're going to start with the more complicated side. So which side is that?
Cosine of x.
Right, okay, this side. Okay, and we want to change all the terms to cosines and sines. So this is already cosine, so we're working with this, right?
Yeah.
So what should we change this to?
1 over cosine of x.
Right, 1
Yeah.
over the cosine of x.
Yeah, but
And then we bring down the rest of this,
you mark it.
equals 1. Okay, tell me what was Susan next?
You mark out cosine of x.
They cancel, right?
Yeah.
Okay, so you're left with 1 equals 1. Not check.
My dad's gonna take his bill.
Okay, what we're going to start with is if you turn your calculators on and go to y equals, as you can see here, if you need to follow along, and put in the tangent of x at y1 and the sine of x divided by the cosine of x in y2. And then you can graph it and look at the graph and tell me what conclusions you can make based on these functions based on their graph.
You know, I think I took it out of radian and it's in degrees now. You may need to change it.
Okay, sorry. When you look.
It's still thinking though.
The way it needs to be in radians.
Yeah, whenever you're graphing,
Give it time to strike.
On the side.
You're
back to y equals.
You gotta zoom 6.
Hold on, hold on.
I don't see it.
Oh my god.
You got that in? Do you have both of those in at y equals? Okay. I'm trying to figure out.
Stop. Alright, I think we're
I
ready.
can't make it.
Hold on, I'm looking.
Oh, it turned off. Oh,
Is the batteries?
it may be.
They got it over here.
Okay,
I just said mine worked.
Okay, maybe it's gonna last long.
no.
Mine isn't working. I don't know why.
Okay, we're gonna hope we actually got this fast enough.
I
to get
have,
batteries down.
all right.
Okay.
Mine has some lines in between.
Does it look like that?
The,
No.
it graph? Let me see your graph.
Just turn it.
Yeah, they're just kinda connected. We are on a different
why
Zoom,
they're
different window. Okay, a guy here on this side, like, had a pretty good idea, but zoom around this side of the room who might not have heard him, know what conclusion you can make based on these two functions?
They're the same.
The range is infinity, negative infinity, positive
They're inverse.
They're the same.
Raise your
They-
hand.
I like your idea.
They're
I
the
don't.
same.
Okay, how can we make sure that he's right? If you go to the table, what do you notice? So regardless of what value you put in for x, both of those functions, the y1 and the y2 are equivalent. See that?